Alright, let's look at Chapter 2. Quick review for your test. Chapter 2 deals with two things. First thing it deals with is the scientific method, and then the second thing we deal with is calculations and units of measurement. Scientific method. In chemistry or in any science, we have a very specific way of solving problems. We call it scientific method. You've been studying it for years. It's a logical approach to solving problems. We make observations, collect data, formulate hypotheses, test those hypotheses, and then we develop theories supported by that data. Observations. Observations use senses to obtain data. We have two types of observations. Descriptive data, which is qualitative, and numerical data, which is quantitative. Qualitative, no numbers. Quantitative, numbers. Qualitative examples would include blue PowerPoint. A quantitative example would be, there are 56 slides in this presentation. Inferences. Inferences are interpretations or explanations of something. Inferences are kind of what we can make an educated guess on or interpret based on our scientific knowledge, what's really going on chemically. Experimenting. We do a lot of experimenting in chemistry. We carry out a set procedure under controlled conditions to make observations and collect good data. Chemists study systems. Now, a specific state of system is a portion of matter in a given region of space that has been selected for study during an experiment. An example of a system. If you were studying fish in a pond, that pond would be your system. Scientific method. We use generalizations about data collected to formulate hypotheses. Now, a hypothesis, there are two things that you need to get out of this. A hypothesis is a testable statement, and it serves as a basis for further understanding. Typically, I like to do an if-then statement for hypothesis. If this condition is met, then this action will occur. I like the if-then approach. There's only two possible answers to a hypothesis. Either your hypothesis is right or your hypothesis is wrong. Either way, if your hypothesis is right or wrong, you're going to modify it and repeat the experimentation cycle. If your hypothesis is right, it's going to become more and more certain every time you perform the experiment. If it's wrong, you're going to completely rework your hypothesis. A little graphic representation. The very first step in the scientific method is to make an observation about a problem. That leads to formulating a hypothesis about that problem. Then we experiment. Then that cycle repeats. Modify the hypothesis, make our observation, and that experiment just repeats and repeats and repeats. Cycle repeats many times. The hypothesis gets more and more certain every time you repeat. Eventually, it could become a theory, which is a broad generalization that explains a body of facts or phenomena. A theory can then become a model, and a model may be used to help or may be developed to support that theory. An example of a model is atoms. Can you actually see an atom? No, but we have several theories that have been designed that kind of help us get a mental picture of what an atom may look like. A model set or either a picture of an atom. It kind of helps us get a picture, but it is based on the theories of atomic theory, based on the postulates of atomic theory. After this cycle repeats many, many times, theories are useful because they predict results of new experiments. We may be able to apply that same hypothesis to a very similar experiment. They help us form mental pictures of processes. This is an example of a model. You can see we start with observations, then we formulate a hypothesis, then we experiment, and the cycle repeats. This is an example of a model. It helps us visualize the processes going on with scientific method. Another outcome, if this repeats many, many times, is a law. Scientific law is a description of how things behave. So we have two possible things, a law and a theory. A law tells you how, a theory tells you why. After this recycle repeats many, many times, we've got two possible outcomes. We've got a law and we've got a theory. Theory can lead to the development of a model, which can then help us predict new experiments, which can lead to further experimentation, and then that process can repeat again. You can modify your theory to apply to something else, and that process can just repeat and repeat. And that's it for scientific method.